Okay, a monochromatic light of wavelength 600 nanometer incident normally on a diffraction grating. The angle subtended by the first order maximum lines is 30 degree. Okay, calculate the number of lines per unit centimeter of the grating. Okay, so alright, okay, so this is about double slit, thin film, single slit, or diffraction grating, many slits. So we can see the keywords here: diffraction grating. Yeah, so this is about many slits. Okay, I want to write it down here: diffraction. So this is the first thing you should identify. Yeah, is it double slit, single slit, or diffraction grating? Yeah, so this diffraction grating, many slits. Right. Okay, information given. We have wavelength in nanometer. You have to change to meter. Angle subtended by first order maximum lines. I see here lines 30 degree. So what does it mean by this 30 degree? Angle subtended by first order maximum lines. So what I can say is, okay, I draw it out. I draw it out over here. Okay, so okay, let's say this one is the zero order bright fringe. Okay, the center, or we call the central maximum. Okay, the central maximum. Okay, and then here we have the first order bright fringe. Okay, in fact, diffraction grating only talks about bright fringe. Yeah, only talks about bright fringe. It doesn't consider about the dark fringe. Okay, so this is the first order bright fringe. First order bright fringe. So what is this 30 degree? Angle subtended by first order maximum lines. Why got S here? Why got S here? So what angle is this? Is it refer to this angle? Is it refer to this angle? This here is a source of light. Yeah, passing through a diffraction grating. Okay, and then got a diffraction happens. So is it this angle? Is this angle 30 degree? Is it this angle? Is it the 30 degree from the central maximum, from the zero order bright fringe, go up to the first order bright fringe? Is that the 30 degree? No, this is not 30 degree, because here you see got S, lines. Angle subtended by first order. First order means n equal to 1. Yeah, n equal to 1. Angle subtended by first order maximum lines. That means there are two first order. There are two first order, top and bottom. Let me draw it out. Okay, there's another first order here. Another first order. You know that? There's another first order bright fringe below. So the 30 degree is not the angle of first order bright fringe to the central bright fringe. No, not that. Okay, instead it is between the angle between first order maximum lines. So between the two angle between the two first order bright fringe at the top and at the bottom. At the top and at the bottom. So it should be this angle. Let me draw it out. So angle 30 degree should be this angle. That's the angle. 30 degree. This is this two. Yeah. So it should be this, the first order bright fringe and at the top, the first order bright fringe at the top, and first order bright fringe at the bottom. So angle subtended by both of these first order maximum lines got S. Yeah? That means these two lines. This line, here got S. It means there are two lines. Yeah, two, or we can say two first order bright fringe. The top and bottom. Top and bottom. Understand? The top and bottom. So angle subtended by these two first order bright fringe at the top and the bottom. Angle between them is 30 degree. Understand? That's the meaning. And then question A, he asks us to find the number of lines per unit length, number of lines per centimeter. Okay, so be careful, this one is in centimeter. Okay, and this question is asking about n. Okay, but the unit is per centimeter. You have to change it to per centimeter. All right, so how to do these questions? How to do questions? So okay, go back to this theory about diffraction grating. Remember, diffraction grating only investigate bright fringe. Okay, let me just copy the one from before. Yeah. So this one, yeah, the same thing. Okay. Oh, well, what happened? Okay. Yeah, this one. So diffraction grating is considered as like in phase sources. So bright fringe still use n lambda. About this n lambda, I already explained to you in the previous example. Okay, for in phase source, the bright fringe always n lambda. Okay, n lambda. D sine theta equal to n lambda. Yeah. So it only has the formula for bright fringe, no formula for dark fringe. We don't investigate the dark fringe for diffraction grating. Diffraction grating only investigate bright fringe. So d sine theta equal to n lambda. Okay, and then the order start from 0. The order must start from 0 because we have the 0 order bright fringe here. You see that? We have the 0 order bright fringe. Okay, so now we want to find the number of lines per unit centimeter. So okay, this n is actually, we can find it using the formula d equal to 1 over n. Understand? D is the separation between the slits. N is the, you know, D is the slit separation between the slits, and n is the number of lines per unit length. Yeah, number of lines per unit length. Okay. So we can find n from here. So first of all, we find the d, small d, and then we find the small d, and then we can find the n, the number of lines per unit length. Okay. All right. So let us use this formula. Okay. Angle subtended by first order maximum lines is 30 degree. So what I can say is, what about the angle? One angle. What about this angle? What about the angle theta 1? Okay. What about theta 1? So if this one is 30 degree, then this one should be 15, isn't it? Divide by 2. So the theta 1 should be 30 degree. Yeah, theta 1 means the theta for first order bright fringe. Yeah, theta 1, the 1 here means you refer to the first order, n equal to 1 bright fringe. Okay. Okay, we're going to use maximum line. Question A. So we're going to use the bright fringe formula, which is d sine theta n equal to n lambda. Now he's saying that the first order bright fringe has theta equal to 15. Okay, theta equal to 15. So I can write like this: theta sine theta 1 equal to 1 lambda. This is for the first order bright fringe lah. First order bright fringe. The n equal to 1. Yeah, n equal to 1. So put in the value, find the d, sine 15 degree, and then 1 lambda. What is the lambda? What is the lambda value? Lambda is 600 nanometer. Okay, need to change the nanometer to meter, SI unit. Okay, 600 nano. Nano is exponent negative 9. Okay. So your calculator in degree, yeah. Remember your calculator in degree. Okay, so let's calculate. Exponent negative 9. Okay, and then divide by sine 15. Sine 15. So I got 2.3182. 2.3182 exponent negative 6 meter. Okay, so I got my d. So now I can find my this one in meter, so I can find my n. Okay, before I find my n, the unit is in per centimeter, isn't it? Per centimeter. So I better change this d into centimeter first before I find the n. Okay, I change this unit into centimeter first because the n is in unit per centimeter. Okay, I change this d into centimeter. So this d is equal to 2.3182 exponent negative 6 per centimeter. Means, okay, I pull it, then I add a centi here. I add a centi. Centi is the value is exponent negative 2, isn't it? Centi is exponent negative 2. Exponent negative 2. Okay, and then I add one more is exponent 2. Understand? It's just the same like you know. Maybe I copy this. See that? Just the same thing like this one. You know that? This one is like this one. You know, it can be like cut off. You know, this one cut off is like multiply 1. You see that? It's just like this one multiply 1 meter. I get back the same thing here. So now this exponent negative 2, exponent negative 2 become the centi. It become the centi unit. Become a centi unit. So this exponent 2, I multiply to inside. I multiply inside, and what do I get? Okay, and then what do I get? Let me see. So the d I get 2.3182. This one become you know, is becoming negative 4. Yeah, negative 6 plus 2 negative 4 lah. So this is centimeter. In fact, meter becomes centimeter is multiply 100, isn't it? Meter becomes centimeter is multiply 100. So multiply 100, this one negative 6 become negative 4. Correct lah? Okay. Okay, now I already got the unit in centimeter. I already got the unit in centimeter, so I can get the n value. The n value in per centimeter unit. Okay, so I put in my d here, 2.3182 exponent negative 4, and then this is a centimeter, 1 over n. Okay, so n is cross multiply, cross multiply this one. Okay, this one go to below, this one n go to the top, and 2.3182 exponent -4 centimeter. Okay, divide, and what do I get? Let's check. 1 divided by 2.3182 exponent -4 centimeter. And the answer is okay, is 4,313.69 lines per centimeter. Or we can say that it is 4,313.69 lines per per 1 centimeter. It means like that. Okay, so is the answer correct? Let me check. Yeah, is the answer correct? Yeah, that's correct. Okay, so that's correct. 4.31 exponent 3. 4.31 exponent 3, or 4,313.69 lines per centimeter. That's correct. Okay, that's the answer. Okay, and then what is the angle between, what is the angle between the first order and second order maximum lines? Okay, what does it mean by this? Angle between, so you want to find theta lah, between first order and second order maximum line. So between the two lines here, so the first one is first order maximum, this is maximum, so first order bright fringe, and the second line is second order bright fringe. So what is the angle between first order bright fringe with the second order bright fringe? What is the angle between? So maybe I can draw it out. Let me draw it out first. Okay, so for question B, question B, okay, this is the light source, and this is the diffraction grating. Okay, and then this is the screen, the diffraction pattern. Okay, let me wait, hold on a second. All right, so and then what I can see is on the screen I can see first order and second order maximum lines. So at the center, I draw the central first. This is a central bright fringe, or called the central maximum. And then I have at the top, I have the first order bright fringe, or first order maximum. And then I have the second order bright fringe, or second order maximum. This is what we call order. This is what we call order. Order means this one, n equal to 2, n equal to 1, n equal to 0. Okay, these are the order. So the question is about the angle between first order and second order maximum lines. Angle between first order and second order. N equal to 1 bright fringe, n equal to 2 bright fringe. Angle between these two. Angle between these two lines. Yeah. Angle between these two lines. That means angle between these two lines. That means, okay, I can say that I have this line, this. Wait. Let me draw it out. So this is the one, and then we have this line here, and then I have another line here. See that? Okay, so angle between these two should be, I can say this one is theta 2, this theta 2, and then this is theta 1. Understand? This is theta 2, this is theta 1. So here you say angle between first order. See that? Angle between the first order bright fringe and between the second order bragg fringe. So angle between these two. Angle between these two two lines. Understand? Angle between these two lines. So is this angle delta phi lah. We want to find the delta phi. Okay, this is supposed to be delta phi. We want to find delta phi. Okay, delta phi. So this is the delta phi we want to find. Yeah, between these two lines, between the first order bragg fringe and second order bragg fringe. Between these two lines, the angle between them, delta phi. So how to find the delta phi? So delta phi is just take the theta 2 minus theta 1. But first you need to find theta 2 and theta 1 before you can proceed. So okay, theta 1 actually already have 15 degree just now. 30 degree divided by 2, I get 15 degree. So okay, theta 1 settle. I already got 15 degree. Okay, that is for first order bragg fringe. Now how about theta 2? Okay, okay, then let me rearrange the information. For the first order bragg fringe, settle. I already got the theta 1. Okay, I already got the theta 1. Now how about the second order bragg fringe? Second order maximum. So what is the theta? What is the theta 2? So what is the theta 2? So I need to calculate. So I use the same formula. D sin theta equal to n lambda, bragg fringe formula. The bragg fringe formula for diffraction grating. D sin theta n equal to n lambda. So now I put n equal to 2. Yeah, n equal to 2 because it's second order bragg fringe. So it's d sin theta 2 equal to 2 lambda. Okay. Now what is the d value? D value in meter. Use the one in meter. Don't use the one in centimeter. Use the one in meter unit, in SI unit. So use the one in meter unit. 2.3182 exponent negative 6 meter. Use the one in meter unit, in SI unit. So and then sine theta 2. You need to find the theta 2. Then lambda is 600 nanometer, isn't it? 600 nanometer. So the nano change to exponent negative 9. Yeah, same as before. 600 nanometer. Nano is negative 9. Exponent negative 9. Okay, so I can get my sine theta 2. I can get the answer. And don't forget to anti-sign. Yeah, take anti-sign. Anti-sign the value. And finally, after anti-sign, what's the answer? Let me calculate. 2 times 600 exponent negative 9 meter divide by 2.3182 exponent negative 6. 3182 exponent negative 6. Okay, I got the answer already. Don't forget, change your calculator into degree, not radian. Change it into degree. Yeah. And then I got the theta 2 is 31 point after anti-sign. After anti-sign, I got 31.17 degree. That is the theta 2. Okay. So I got my theta 2 already. So I can find my delta theta. So my delta theta is theta 2 minus theta 1, which is what? Delta theta is theta 2. Theta 2 is 31.17 degree minus the theta 1, 15 degree. And then the answer is, what's the answer? Let me check. Okay, so 31.17 minus 15. So the answer is 16 16.17 degree. That's the answer. Okay, is the answer correct? 16.17. Let me check. Yeah, the answer is 16.15 degree. 16.15 degree, which is also 16.17 degree. That's correct. That's correct. Okay, so that's the angle between the first order and second order bright fringe. Okay, it is 16.17 degree, which I got from calculation. Okay, the angle between the the first order bright fringe, theta 1 and theta 2. Okay, and theta 2. Okay, so that's the answer. I hope you understand the questions, and okay, that's all for these questions. I hope you understand. Any questions, you can just leave a comment below and I can try to answer. Okay, bye bye.